Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
Today, I had the opportunity to speak with Sean Falconer, Senior Director of AI Strategy at Confluent. Our conversation ranged across a bunch of different topics, but the main thrust was digging deep into agents. What does it mean to be agentic? Is there a spectrum of agency? Where are agents taking off, and what are the biggest blockers? How should we conceptualize an agent as a unit of software code, and how does it fit into a larger infrastructure? Who should be building agents, and how? This could have easily been a much longer conversation, but I do feel like I left with a concrete definition for what had previously been an amorphous marketing buzzword. Maybe you'll feel the same. Without further ado, let's get into it. Sean, welcome to the Analytics Engineering Podcast. Great to have you.
Yeah, thanks for having me. Happy to be here.
Both to apologize to you as well as listeners. As we're recording this, I am on a lot of substances. I'm on a NyQuil hangover, and I've got Sudafed running through my veins today. So we'll see whether they balance each other out. But you may have to carry the conversation today. We'll see how it goes.
Yeah, that's unfortunate. Yeah, I think like NyQuil's kind of like don't make any plans quill should be what it's called. It's just like
yeah, that's it's good. Normally I do better the next day, but this morning for some reason that's not how it went. So I've been excited to get on the calendar with you. You've got a lot of really interesting experience. You're doing some interesting work right now. Can you give us the TLDR on the stuff that you've been interested in over the course of your career and what you're working on today?
I've always kind of worked in I guess like the intersection. If you imagine a Venn diagram between like data, knowledge engineering, and AI. Going back to my education, I spent basically from the time I was like 17 to 30 in university, studying computer science across 3 different degrees, eventually doing a postdoc. Then I went into industry, being a founder of my own company, and then to Google. And during that stretch, I worked a lot on sort of conversational systems, early conversational AI, at various communication platforms at Google. And then I worked on the AI, sort of the privacy security side of AI for a number of years at a company called Skyflow, where prior to joining Confluent, where I lead our AI product strategy. So I've seen kind of all different forms of the business, working both in technical roles and also more on go-to-market roles, and also on the product side.
I did find that interesting. A lot of times when you start your career in a very technical space, you don't tend to have the breadth of go-to-market and technical experience that you have. What made you curious to go kind of over on the go-to-market side of the house?
It was really, I was forced to do it, to be honest. Like, from being
as a founder.
Yeah, exactly. Like when I started, was a co-founder of the company. I was probably not the guy that you wanted to put in front of a customer on a sales call. It was not something I was comfortable with. I was about as hardcore engineering as you could probably be, having spent my entire life essentially studying, engineering and also working as an engineer through those years on the side. So, but when you're a founder of a company, like you have to figure that stuff out. There's just nobody else to do those things. And there was lots of times where we were extremely low on resources, didn't have money to pay people to do certain types of jobs. So you just end up figuring it out. It's like, okay, well, it's great that we have a product, but how do we get it in the hands of people? How do you sell it? How do you market it? And you have to just, roll up your sleeves and figure that stuff out. So a lot of mistakes I made along the way. Like I think we did everything wrong that you probably can do as a founder at various stages of that company. But I learned a tremendous amount. I had to build out a marketing team. I had to build out a SDR team, all these things I never imagined doing. But I learned a ton about, that side of the business and grew to really respect it as well. I think a lot of times when you're sort of heads down on the keyboard, I can even remember my first job as an engineer in college, the marketing people coming in and talking about like branding and like upcoming conferences. And I was just like, what do these people even do? Like, why do we pay these people? And it's kind of a ridiculous stance in retrospect, but I think having gone through that experience and also realizing how hard it is to market a product and sell it, I just really, really grew to respect that side of the business, and it's a really, really hard job.
Yeah, I find the paths that your brain takes in solving marketing problems to be an interesting one. It's a neat problem space.
Yeah, and I think actually I always had I guess kind of like a unique perspective on it as well, having come from an engineering background. I think that there's certain things in marketing that I could be really effective at because I was always thinking about like how do we automate this process? How do we optimize this? So
Yep.
sort of there's a part of marketing that's very like optimization math driven, like of demand generation. It's all about funnel optimization and things like that. And I think that part of the marketing side came very natural to me. I think things that are more on the like branding, creative, I think that's something where like I ideally hire somebody to handle that kind of stuff. I have an appreciation for it, but I don't know I'm the go-to guy for it.
You were at Google in an interesting period. You said you were working on conversational experiences, but I think that you were there really just prior to the launch of ChatGPT and the world-changing moment that became. What did your work at Google look like in this pre-ChatGPT era? And did it seem obvious to you that we were kind of hitting a moment? We're like about to hit a moment?
So I'll answer the second part of that first. Did I think that we were about to hit a moment? Not really. Like having worked in AI for so long, I saw a lot of these different supposed breakthroughs, especially when it came to like conversation. I can remember being doing graduate school, and I think like Microsoft, I think it was Alice they had come out with, and there was a lot of hype around it, and it was like extremely disappointing. Like the actual
Yeah, that product was killed in like less than 2 weeks or something,
Yeah,
right?
I mean,
Yeah.
I think they ended up like exposing the internet and learned all kinds of awful things and said terrible things, so they like killed it immediately. So there was a lot of these examples of like where people got really excited about it, but then if you're kind of in that world, you're like, this is not like that novel or interesting. So I kind of even when ChatGPT people started talking about it, I was like, oh, is this going to be like another Alice? So I didn't really see that at the big like prior to large language models really bursting on the scene with ChatGPT, being fully transparent, but in terms of like what the experience was like, so I worked on I was on the Google Assistant team for a while. I worked on Dialogflow, a bunch of their business communication products, mostly focused on sort of the developer experience, like what's the API design, what are the developer toolings around it. That's like really where my team owned, and sort of helping people understand how to move from kind of just like one-off messaging to more conversational style, conversational design. And we did a lot of this also at my startup, like through text messaging in the early days of that's how we built a sort of two-sided marketplace that would allow people in blue collar trades and other sort of higher turnover skilled trades, hospitality, restaurants, stuff like that to find jobs. We did it all through initially through text messaging and then that evolved into mobile apps, but it was all very conversational style. And it was just really hard to make those systems uh perform well. Like there you could build them in such a way that if people followed the happy path, they could seem like magic. But as soon as someone tried to veer off the happy path, it was really, really difficult to make those systems robust. And that's where I think a lot of chatbot type experiences got such a bad name. Like it was such a turnoff for consumers because you get into this like loop essentially where it just leads to a tremendous amount of frustration because you can't get the bot off of whatever sort of flow that it's currently working on, and then you just really want to talk to a person. And then by the time you talk to that person, you're extremely angry. So it's like bad for everybody.
You're now spending your days at Confluent. You've written a bunch of stuff that I want to talk to you about. But can you just give me a sense of like what does it mean to be senior director of AI strategy at Confluent? Are you like running a team that builds products? Are you talking to customers about use cases? Are you writing a lot of blog posts? Like what is the job actually?
It's probably all of those things. Originally, I was hired as Confluent's AI entrepreneur in residence, and really that job was to think about where does Confluent need to go as a company in relation to where AI is going. So thinking about beyond even the roadmap of where we are now, but where is what do customers need? What are the market trends? Where we go? Where's AI as an industry going? And how does Confluent fit into that picture? And uh, and during that time, I was doing a lot of thought leadership and writing about this topic and how you bring these kind of worlds of data streaming and AI together and why it makes sense. What are the use cases where you'd want to leverage these technologies and things like that. And that eventually evolved over the last month or so to now moving into the product organization where I am actually leading our R&D efforts in relation to AI. So I we have a small product management team that owns all the AI efforts and product investments, and then we have an engineering team that I work with on a daily basis to try to bring that vision to life.
Maybe towards the end of our conversation, we can circle back to the Confluent's place in the AI ecosystem today, because I am interested in it. I think Confluent and DBT Labs are both playing in the data infrastructure space, and it's an interesting question. How does data infrastructure and the products associated with it like interact with AI? How does it impact them? But let's go back. You wrote a blog post a while ago that talked about the 3 waves of AI. Talk to us about those waves, and I feel like you inserted like a wave 2B as well. So I don't know if it was 3 or actually 4.
I usually talk about it as 3. So the 3 waves are essentially purpose-built models or predictive AI, um, generative AI or foundation models, and then now agentic AI. So with purpose-built models and predictive AI, that was really what I studied in school, was a researcher in for a number of years, sort of statistical models that we've been using successfully in software for decades now. And that's really what most people had associated with machine learning or AI or however you want to kind of, bucket it, for the last, 50 plus years.
Where the use case is like the most prototypical use cases like fraud prevention, something like that.
Fraud, spam detection, these types of things where you're taking some input and you want to classify it into some sort of bucket. Or you can do things like clustering, where you're taking a bunch of representation of inputs and you're figuring out like how do I cluster these things together in different groupings. So tremendously useful, but rigid in terms of its like reusability and flexibility. So typically what you're doing is you're taking very application domain specific data and you're going through this kind of offline batch process to train an application domain specific model. And then that model is trained to do that one thing and that one thing well, but it's hard to kind of pick up that model and start doing something new. So if I have my fraud detection model, I can't just start doing image classification with it. But the advantage there from a business perspective is that during the training process, because you're usually using your data to train these things, a representation of your business and like whatever your understanding of your customer and your business data is essentially baked into the model weights. And with this, the next wave of essentially foundation models, which is not a replacement. I want to be clear, like these things are complementary. Just because we have foundation models doesn't mean the purpose-built models go away. With foundation models, you almost have the opposite problem where they're trained on essentially everything that exists on the internet. And it goes through this, long process of deep learning to build these gigantic models that are then wrapped up, in a nice API that anybody can call. And, as a user of those models, and the APIs, I don't need to know anything about how the model was constructed to take advantage of them. It was great. It democratizes access to these, and they can be used for essentially infinitely many things. I can do all kinds of different things with these models, which I think is where a lot of the fascination comes from. But on top of that, or the challenge, I guess, with these models is that they are very smart about general public information, but dumb when it comes to essentially your specific business needs because they weren't trained on your business information. They don't necessarily have a representation of your customer in baked into the model weights. And essentially, this changes the requirements around the data. They have sort of different data needs of how you actually use those models. Because in order to actually get business specific information out of them or tailor them to specific use cases, it's pretty much all about your ability to correctly contextualize the prompt that you feed into the model in order to get some sort of result that's relevant to you. And this changes the nature, I think, of how we have to think about data. It puts a lot of responsibility on the users of these models to figure out, like, how do I go retrieve that correct context from all the different possible locations it could be? How do I make sure that it's a fresh representation of whatever that entity is that I'm feeding it in so that I don't lead to a situation where the model is generating something that's incorrect or a hallucination or invalid in some way? And then we've gone from so if we think of this in sort of the physical world with purpose built models, they're really like a reflex where you train them once and they react. So it's like I touch the hot stove, pull my hand back. Very useful, but not that flexible. Foundation models is like now we're introducing like a brain that can reason. It can explain things in the way that like a human might explain things. And you can, if you could correctly ground the context in your data, you can get something valuable to the business. And then we're going from there to this third wave, essentially agents or agentic AI, where it's not just about a brain; it's more of a like a full body software system. So you have the brain, which is the foundation model that can do some reasoning. It can figure out how do I dynamically figure out what the workflow of execution is. You have tools. These are almost like the appendages of the software system. It can take action, so it can actually go and change records or something like that, just like a human can go and perform different things. There's sensors, there's inputs, so it's a much more of a full body system. It has the same sort of data challenges I think that foundation models have. It's all about the correct contextualization of the data. You need a combination of historical reference data of how what's relevant through the history of a particular customer interaction, but you also need to know what's happening sort of in the moment, how to what's the situation right now so that I can correctly contextualize the prompt. And then on top of that, I can go and gather resources, take actions and things like that. So it's much, I think that's what the compelling part of it is. One is agents are able to dynamically make decisions, whereas traditional software is much more of a fixed control flow. And then on top of that, you end up with all these challenges. I think from an engineering perspective, that these end up just being like distributed systems that you have to manage at scale.
Let's dig into this. And this is, I want to spend a bunch of time here. One of the things that I think is interesting, you said that the waves build on top of each other. And I certainly agree to a large extent. But one of the things that has been interesting to me as I have, in my own amateur way, navigated the AI space more deeply is how often we are using the transformer architecture and the innovations that have come out of that to solve problems that we would have solved with kind of quote unquote classical machine learning in the past. I've heard of recommender systems that have been completely refactored relative to the way that they worked a decade ago, et cetera, et cetera. Do you find that some of the advances in the kind of wave 2 large language models are displacing some of the traditional ML approaches?
I think it can, but I don't know that it always makes sense. So,
Okay.
for example, you can certainly do like sentiment analysis using a large language model, but does that make sense for your use case in terms of like how quickly you can do that operation on a large language model? And then also, if you have an existing model that was trained to do sentiment analysis that does it in a reliable way, it's going to be a lot less expensive to run that model and probably performs faster. So I think ideally especially when we talk about agents and doing some sort of workflow or composite set of tasks, you're realistically combining probably multiple techniques and multiple models. So, but I think because everybody likes that these models, the big foundation models can do essentially everything, we end up like applying them to everything without always thinking about, okay, well, we actually have something that's working to solve this problem. Does it make sense to use a large language model? And they can do the job, but it's a little bit sometimes like cutting your steak with a chainsaw. Like, can you cut your steak with a chainsaw? Yes, but would that make sense for probably
That's
not.
an interesting metaphor. It's very that will stick with me. I do have a chainsaw and I do eat steak, and so I can identify with that. Okay, I hate to play the grumpy old man role, but agents is one of these terms that I struggle with. It doesn't feel like we've come to a super precise definition about it yet. You said a bunch of things about agents that I think are all true, but I wonder if they don't get to the like precise nature of what makes something agentic. The way that I think about this is an agent is just a software system that at its heart uses a language model in order to make some decisions that the software system previously wouldn't have been able to make. Like if the LLM wave 2, I think you were describing it as, where there's essentially a prompt, an LLM, and a response. That is like barely a software system. It doesn't have a lot of control flow involved in it. In agentic AI, you have a more sophisticated software system that cedes control from the developer of that system to the agent at important points, and it gives it agency, which is why the term I think is Is that a reasonable way to think about it?
I think you're right that there's no like agreed upon definition of what an agent is. And there's a lot of things that are now being called an agent that like a year ago probably wasn't called an agent.
Yep, including the entire Salesforce annual conference.
Yes. And the way I like to think about it or explain it is essentially aligned with your explanation. Is it's a software system that has the agency to make some sort of decision about the control logic. And that could be just dynamically figure out, okay, well, under this situation, I need to go and gather data from this system, or I need to go and perform this particular action. Or, I have I want to perform a task, and then I'm going to hand off the output to some other agent. And the sort of graph structure, the edges between the graph are sometimes dynamic, depending on what the task is in hand and what resources I have available. Uh, so that's the way I like to explain it. Now, I do think that real world agents that are successful in enterprises today have relatively low amount of agency versus being a little bit more of like a kind of a workflow thing that you're taking some sort of existing human process, you have a playbook, and then you're sort of splitting that up into a bunch of agents that kind of talk to each other. But the sort of graph structure or workflow execution is relatively predetermined. And sometimes there's a little bit of agency there in terms of, okay, well, under this circumstance, we go gather data from this system, or we, call this this node in the graph versus this other node. But the structure is relatively fixed. And I think the reason for that is that the kind of, I don't know, this like utopia era vision of agents where I just give agents my API keys, give it an instruction, and it loops, infinitely on doing inference until it solves all my problems. It's just we're very, very far from that as a reality. You want to get as much control of these systems as possible to have confidence that they're going to be able to deliver a result reliably. Because if you had an agent that was figuring out how to route meals or for DoorDash, and one out of even 500 times it gets it wrong, and it delivers your meal to someone else's house, that's not a satisfying result. So you want to essentially have as much control over the output and the reliability as possible. So you're adding as much determinism to this kind of inherently non-deterministic process as well.
I think you're being generous. If DoorDash got 499 out of 500 deliveries correct, I think that would be a win. But I see the larger point. You just introduced a concept there that is kind of like a spectrum of agency. So we have for a long time now as an industry talked about the spectrum of intelligence, and it's very famous in the self-driving car example, like level 1 through level 5, blah blah blah. It seems like we need to also have some kind of like well-defined spectrum of agency. Like how much control are you ceding here? And there are real trade-offs there. I remember I recorded a podcast. I don't remember. It was probably 18 months ago or something like that with someone named Yohei Nakajima, and he had built a thing called Baby AGI, and it essentially just like you described it, like ran in a loop literally forever, and you could give it tasks like go make me a business, and it implemented this kind of like plan, execute loop.
Yeah, the React loop.
Yeah, and yet it was very clear that it like could not actually be the CEO of a business. It would like get stuck and like whatever, and sometimes it would do better than others. But the journey since then has been, I feel like, kind of trying to find the right use cases and the right place where you want to cede control in order to construct agents that actually like consistently add value as opposed to just novelty.
Yeah, I think that's true. Like, I think like where I see like our customers at Confluent being successful is a lot more about sort of often like augmenting existing internal knowledge work. So if I have a support ticket comes in, and today I have to have somebody look at that support ticket, go figure out what's what resources relate to the support ticket, look at internal wikis, gather a bunch of information, generate a response. Well, if I kind of understand relatively like what the inputs are, what the expectations around the outputs, I can offload a lot of that to essentially a multi-agent system that executes more like a workflow, where it's going to go off and be able to gather these resources, and it can get to a place where it's generating sort of that first draft response, and you still have a human in the loop that's validating that response is like reasonable start. But that's, I think, where I see people being successful today, not kind of a baby AGI system where it's very, very hard from like a testing eval perspective, if the input can essentially be unbounded, if you have these like very open world problems of like, hey, ask me anything and I'll go and figure out how to generate a response to it. Like, how do you test for that system? You can't, because the variance level or the size of the input is essentially completely unbounded. So I think you have to think about from a business perspective, like what is the closed world problem? Like what are these things where I kind of understand what the input is. It's a insurance claim. It's a support ticket. It's data coming in from a bunch of IoT devices or clickstream. These types of things where I understand. Okay, well, based on this event or sequence of events, now I want to go and do some automation on this and hand that off to the essentially the multi-agent system to figure out how to generate a response or how do I action this to serve some sort of human need.
I'm thinking about this as we're talking. I feel like agents have taken off a little more in an enterprise context than in a consumer context. Do you think that that is a true statement?
I think so because a lot
Here,
of
here's my hypothesis.
yeah
Tell me
yeah
what you think about this. I think a lot of consumer use cases when you don't need as precise of an answer, and so kind of the wave two just prompt answer is good enough, and then when there are tasks that you want to kind of just hand over that require a high degree of agency, they're generally pretty complex tasks. Like book me all the things for a trip. I mean, like that's pretty hard.
yeah
Whereas in an enterprise context, you can add a tremendous amount of value doing some really small, well-defined thing because you're gonna multiply it times whatever thousands of times that you run it a day.
yeah, I agree. I mean, if you look at any business, there's going to be thousands of places where they could optimize some sort of existing workflow. So they have a huge backlog of places where they could be using some form of call it an agent or AI system, compound AI system that can essentially help them offload some of that work that a person's essentially responsible for today. So I think they are ahead versus like the consumer experiences where if I'm going if I can go to some sort of travel site and I say book me a trip and it can ask me a couple questions of like you want a beach vacation, some parameters, and it goes off like the expectation that that is able to deliver correctly is probably going to be very very high. Whereas if it's more, hey, I want to be able to do a first pass, augment some existing knowledge worker, you could lower sort of the threshold of what good enough is. Um, and I think my guidance for businesses when they start to try to invest in these technologies is they really need to look at sort of these things that are like high ROI so that if you do pull it off, you feel the impact of it and it feels good, but relatively low effort while also balancing sort of the risk tolerance of things not necessarily being 100% accurate.
So one of the things that I feel like we don't always have a clear mental model as an industry around what an agent is actually just how it is invoked. How does it run? And you wrote a little bit about microservices, and I find this to be a very useful mental model. A microservice lives on a server. It is just sitting there waiting for a request. And when somebody makes a request of it, it has a typical request response flow. It just serves back a response, and then it's done. And it's just waiting for the next request. Is that the architecture that you imagine agents taking?
I think from a deployment standpoint, an agent's no different than essentially a microservice. It's a microservice that has access to an LLM and additional context. Now, there might be some additional constraints around state management that could come into play, especially when you think about
Because microservices generally want to be stateless.
stateless. Yeah. But I could have a situation where, let's say, I'm doing some, the agent's job is essentially to reach out to a customer to let them know that they need to pay their bill. But then as it's actually processing that, it turns out the customer paid the bill from the time from essentially during the delta between that initial event and but prior to sending the message to the customer. Then I want to be able to ideally factor that in as a new version of essentially the context and state. So I need to have some understanding of, okay, this was the current state. My understanding at the model level, this is the current state, and then this is the new state of the customer. So there is some state management that's ideally taken into account in these like more complex scenarios, so that you don't end up like annoying in a customer where it's like, hey, why are you telling me to pay this? I just paid this like 3 seconds ago. That leads to potential confusion and a customer support call and all this sort of stuff. So that's kind of the ideal. But realistically, from a deployment standpoint, these are no different than microservices because you want to, I think, like, especially for agents, you want them to be relatively purpose built. Kind of going back to this idea of like closed world problems. Like, I want to understand what the expectation is around the input, what's the shape of that input, and what are my expectations for the output. And that input's going to come in through some kind of request. The agent, even though it's an agent, is still just going and doing a bunch of processing against that request. And then at the end of the day, it's going to spit out some sort of output as a response. And that could be asynchronous, it could be synchronous depending on how you're designing it. But that's pretty much it. It's not really functioning any different than anything that we've done in like data processing for decades.
Sometimes when people talk about agents, they the kind of weird ephemeral way that they talk about them makes me think of the 1990s anime movie Ghost in the Shell, where it's just like, there's something living out there on the internet and who knows what it's doing. But we have these things. They're called demons or servers, and the internet is made up of them. And this is like actually not a new concept. The thing that maybe seems unique here is that because there's more agency that they have, you could imagine them being invoked absent what you would classically think of as a microservice request. So like microservice request is always going to come in because you have some like very clear amount of work that needs to be done. It does the work, it stops. With agents, you could imagine just spinning up making an agent request and saying, here's the current state of the system. This applies especially in our context in analytics. Go see if anything has changed about the system and see if I need to like raise my hand and trigger something else to happen, which is not typically the way that you would think of a more kind of imperative system working.
I think like one of the disconnects I see with agents right now in the industry too is that a lot of people still think of these as like these human prompted or human invoked experiences. Like the the interface to the agent is a chat interface, but I
Yeah.
think that's not the reality of what's going to exist in, especially in the enterprise sort of B2B businesses. It's going to be a lot more of these kind of like a daemon that you're talking about. It's these like long running, always on pieces that are embedded into your infrastructure. And they're going and reacting to certain types of events, or they're always looking at your data systems to make sure the data is correct. They have a job to do. And then it's not about going and asking them to perform that job. They're doing that job automatically based on however you set up the signal to have them essentially react. And I think that's where we're going as an industry a lot more than these kind of like user prompted chat based experiences. And maybe that's sort of the difference between why we see less of this in the consumer world, where consumers are thinking of chatting with these types of systems versus these things that are just always on doing work on my behalf.
The idea of agents in observability, whether it's like business observability or system observability, whatever, like it's basically always been clear to anybody who operates in observability that there's way more data that is like exists to be looked at than any human is ever really looking at. And the idea that you could have processes with agency going out and looking at that and just bringing you interesting results back to focus your time, it seems like highly useful.
Yeah, I think in the number I heard from like the early BigQuery days at Google was that I think like 60% of data that sits in the BigQuery data warehouse is never ever touched. Not even like a select star, like doing doing a like a table scan. It's never touched. So most businesses are sitting on petabytes of data that they never ever are able to like get anything out of. So if I could have, especially as we drive down token costs and things like that, so you're less worried about the expense of this. Could I have a system that's like always on, that's going and analyzing my data, looking for insights, or even you think of the sort of the real time use cases where people collect a ton of event data driven from their applications today, and they hold on to that data in their data lakes and their warehouses and so forth. But it's a lot of times hard for them to do anything with it because there's a huge amount of data. But if I could have something that's kind of always on and as those events are flowing in, to alert me that, hey, like a bunch of my customers suddenly are complaining about this particular product, and I don't have to wait until it becomes a really big issue, but I can go and take a look at that and figure out, do I need to alert somebody? Or on the you think of the on-call engineer that has to get woken up at 2 a.m. because some sort of alert goes off. Well, if I could have an agent that's just listening to those signals and then going and doing some of the investigative work up front, pulling in related pieces of data and figuring out like should I wake somebody up for this or not, or is this a non-issue? They don't necessarily need to fix the issue, but if I can even gather the materials, and then when I do wake the person up, it's like, hey, here's like the 5 things you should look at. Here's what we think the problem might be. Let's at least you have a start of that job versus like coming in and just knowing something is wrong and trying to figure that out.
Let's say that I am a software engineer. I want to build an agent. What am I using to do that? Am I starting with Python? Am I using a framework? Do I use your classic, GPT-4? Do I? What's the kind of modern tool set here?
Well, I think it depends a little bit on like who the audience is and what the goals are. If this is a hobby project, you can probably use almost like any off-the-shelf framework. There's lots of great frameworks out there from all the various CSPs now. Like Microsoft AutoGen is a great firmware. Google has ADK. There's LangGraph, which is very probably the most popular framework for starting with LangChain and then LangGraph, Llama Index, Crew AI. Like there's just a plethora of these things. But I think where things start to get interesting is when you're going beyond hobby project. It's just like if I'm doing a hobby website, I could build that using any technology, serve it anywhere. It's not a big deal. But when you're going beyond that, sort of demo, POC, hobby to deploying this thing for real in an enterprise, then I think that's where things start to get interesting. And the there you have to be thinking of this more as like a traditional software system. So, what am I doing for observability? How do I recover from errors? How do I understand what's going on? Like I think some of the challenges with building agents right now is that, especially when you're doing tool calling, when it works, it's fantastic. It looks like magic. When it fails, it's like I have no idea why it failed and what the problem is, and you can get into the situation where you're spending a lot of tokens on loops and stuff. But in terms of like where to get started, I think from a model perspective, I usually tell people, and I think this is pretty consistent advice with anybody who's built a bunch of these systems, is start with one of the frontier models, like one of a GPT-4 or a Claude or a Gemini model, like one of the models that is sort of one of the top performing models, so that at least you're kind of starting with your best case scenario. And once you've built something and you're happy with it, you can always look for a lower cost model and see how that impacts things. But I would say like take that that off the table of like, hey, I'm going to start with like a really cheap model because that could lead to a lot of iteration frustration, and it's better to kind of start with the best in class and then try to ramp it down and see if you can get something better. And then in terms of frameworks, I think a lot of that depends on um, people's personal preference. There's kind of pros and cons to each of them. There's some really good articles out there that compare and contrast these things. But I think where I see consistently a lot of people who are building agents run into challenges with whatever framework they're using is that sometimes the frameworks just get in the way where they have too many levels of abstraction. And when you start to get into these like real world deployment scenarios, the levels of abstraction can become a challenge to understand what's actually happening when errors happen. So that's like one thing I would be conscious of for anybody who's looking to build some of these experiences, is just think about how do I actually trace what's going on when things are working or not working. And then also a big factor here is ideally you have some way of kind of replaying sequences of events as well, because so much of this is iterative development. It's like, okay, I created this prompt, and then I want to evolve the prompt later. I want to create a new version of the agent. How do I do that and test it against sort of production level traffic without having side effects? So I need some replayability. I need to understand what's going on. So all these things have to be taken into account when you start to get into these real world situations. And then the other big thing I would encourage people to do is really think about not building like a singular monolithic agent, but think about decomposing these into essentially a system of agents or multi-agent system where you have sort of smaller units of work defined as these sort of purpose-built agents that work together, collaborate together to solve a more complex problem. Because that's going to help a lot with your testing and reliability, helps with your deployment as well. And you can really, even if you have like a team working on this, you can task teams to specific parts of the process, just like any sort of microservice architecture.
It's a great overview. I could ask you about a million follow-up questions to that. Maybe just a really quick one. You mentioned start with a frontier model and then adjust from there. Are there models that are known to? I kind of assume in an agentic context, like response time matters maybe a little bit more than it does when you're in a chat interface with a human user. Are there models that are becoming favorites for developers of agentic workflows, but balancing response time and like decision accuracy, this kind of stuff?
So I think the response time is very context dependent because if I'm replacing some human process, even if the response time of the model is slow, it's probably faster than a person's going to respond. So it doesn't, and also if I can, it, I think a lot of it comes down to also in given the context, how big a deal is it to have like a really accurate response? Because if a more accurate response takes a little bit longer, and we're talking like a few seconds versus 100 milliseconds or something like that, then I would optimize for a better answer, even if it takes a little bit longer, especially if it's something that's like critical. So that's the way I would think about it. Though from the frontier model perspective, I think that the ones that I see the most are, Claude from Anthropic, GPT-4, some version of GPT, of course, because a lot of the challenge sometimes with agents is, especially if you're doing tool calling, is how good the model is at figuring out which tools to call. And typically, the the models that are sort of from the big model companies do that a lot better and more reliably than some of the other ones. So you have, I think that's like where I would really concentrate my testing. And if there's parts of the agentic process that doesn't require tool calling, then maybe you can get away with some other type of model. But I think tool calling right now tends to hinge on having a fairly meaty model to be able to do that reliably.
That's fascinating because you can imagine in an agentic context, you might have really a lot of different tools available to you, and you would get very different paths in the logic flow depending on which tool you call.
Yeah, and if you have too many tools, sort of wrap, and this kind of goes back to my advice around making sure you're decomposing these into smaller units of work versus like one monolithic agent. Because if you try to stuff all your tools in one request to a model, generally that you're going to get a less reliable result. Like once you get above like 5 to 7 tools, even the best models start to struggle.
My sense is that we are really at the very, very early stages of actually deploying this type of software system into companies around the world. The scope for automating processes, existing processes, and creating new business processes that never would have been able to be done by humans before. It just so massive. And my belief about where we're at right now, and I'd love it if you would disagree or refine this, is that it's not fundamentally that we are lacking the technology required to do this. My guess is that it's a little bit more about org structure, and that historically, the people with the skills required to build systems like this, they're often a different part of the organization. They're used to those teams generally think about building externally focused products that customers can interact with, whereas these are often much more internally focused systems, and the people who know about those business processes do not themselves, they're not software engineers, and they don't have direct relationships with software engineers who could build this. What do you think? Is this read right?
On the first comment about where we are in terms of people actually deploying these things, I do think that there has been, even over the last 6 months, really a shift in the industry from sort of just science experiments and POCs to people actually deploying things. Like I've talked
You're
to,
seeing stuff in production.
yeah, I've talked to a lot of customers recently that have actual deployments in production. Talked to a bank last week that says that in the next year they're going to have 20,000 agents deployed in the infrastructure. So there is people who are really sort of at the edge of agents and AI right now that are really pushing because that's where they see the future. But I do think that your point about the org structure being a challenge is a reality. Like I think a lot of times the wrong team gets tasked with some of this work. A lot of times because
What's the
it's
wrong team?
yeah, well, a lot of times we think of AI work as like, okay, well, that's like what the data science team or the ML engineering team does, but it's a lot different building models versus building software on top of models. Building software on top of models is more about traditional application engineering, and when you're whether these are internal facing or customer facing, you're going to run it's a lot more about how do you platform this thing, what's the deployment scenario, how do you run these microservices at scale, how do you do disaster recovery, like the types of things that app engineers and platform engineers are used to dealing with, not necessarily the ML data science teams and a part of the organization. So I think like where I've seen some success in organizations is that they end up building sort of a dedicated sub team that has a mixture of these skills, and they're essentially just working on these experiences across different business units and things like that. So I was actually
Hmm.
at a customer
So
site
they
yesterday.
act as a center of excellence internally to get these apps built.
Yeah, exactly. And I think that's where I've seen a lot of companies be successful right now is they build out these teams that have the right mixture of skills, and they're going around to different, taking inputs from different business units, and they're building these experiences. Because I think you're exactly right. Like building these things are successfully, there's a lot more. It's kind of like 99% sort of software engineering and a little bit of AI work. And that aligns a lot more with sort of the typical people who are building apps in the app stack.
The parameters of a production agent are the demands that it places on its underlying infrastructure, the needs for data, all of this stuff are, I would think, pretty different. You just mentioned response time. Like I could imagine that the request response loop is meaningfully longer than a traditional microservice. Maybe that means you have to like think about concurrency different. You mentioned before you have to think about state management differently. Like what are the kind of technical stumbling blocks that folks who want to build 20,000 agents internally are going to run into?
Yeah, I think you do have to think about a lot of these being just kind of longer running asynchronous tasks that are more we use the daemon analogy, like these kind of long running services. And it could be something where the agent has to go and perform work for several minutes or longer, depending on what it is. So you can't really be building that with a traditional sort of point to point request response system. I think that's where you're going to run into challenges. Or one of the other challenges I see our customers sometimes struggle with is they start out with a bunch of independent sort of proof of concepts or demos to solve different use cases, and then they realize, okay, well, we got like 20 of these separate projects going. We need to start to consolidate this stuff, and they start to consolidate it. Maybe they put kind of like a supervisor agent that manages all this stuff. But if they're using some of the existing frameworks, it's very easy to build that essentially as one gigantic monolith and deploy that. And then you're going to run on all the challenges of trying to scale a monolith. So it's a if you're going that path, it's a lot better, I think, from the get go to think about deploying these as separate services and then using. My guidance is always use some sort of event driven architecture. That could be Apache Kafka, coming from the Confluent world. But there's other ways of serving these needs as well. But you really have to think about like, how do I do this in an asynchronous way? How do I do it non-blocking so that these agents can go and do their work and then come back when they have information to let me know, hand that off to another system. And also, how do I do that in like this like decoupled way where I don't have these explicit dependencies kind of like hard coded into the infrastructure? Because ideally, I want to be able to add new agents as new types of experiences I need to serve or replace agents. I want to do that in a way that doesn't could put risk taking the whole thing down because of all these explicit dependencies. Kind of a lot of like traditional challenges that people run into, running any kind of distributed system at scale. These all apply, and the same learnings from those lessons that we've been doing for the last decade apply to building these kind of AI systems as well.
That's probably a great place to end it. That was, I am excited about the agentic future, and I appreciate you making it more concrete for us. I feel like I can get my arms around this in a way that is much more productive than a lot of the way that folks talk about it. So thank you.
Yeah, well, fantastic. Glad I was able to shed some transparency into the realities of actually building agents today. So, I mean, I think I just go back to like, if you're a software engineer and you've been building applications, microservice architecture for a long time, like all those skills are ever more relevant today. Like none of that stuff's going away. And I think one of the disconnects I see, and maybe this is one of the challenges with the sort of the org structure of tasking the wrong team, is you end up with us kind of repeating our past with building these kind of like monolithic things that are never going to be able to go from internal demo POC to an actual production system.
I got it. And I'm sure that as we continue to move down the maturity curve here, we will see new tooling open up agent creation to more and more folks throughout the business. But it seems like it makes total sense to start with software engineers, and glad to hear that we're getting off the ground there. Sean, thank you so much for joining me.
Thanks for having me.
The Analytics Engineering Podcast is sponsored by DBT Labs. I'm your host, Tristan Handy. Email us at podcast@dbtlabs.com with comments and guest suggestions. Our producers are Jeff Fox and Dan Poppy. If you enjoyed the show, drop us a review or share with a friend. Thanks for listening.